So these are things that you should know how to do or know about, right? If you're asked a question about something being concave up or concave down, okay? Concavity is referring to the rates of change, right? Concavity refers to rates of change. So whenever we're talking about concavity, it's either rates of change are going up or rates of change are going down, right? Increasing or decreasing. So remember, your rates of change are the tangent lines to your graph. So the one on the left starts off very, very negative and gets less negative, eventually gets to 0, and then becomes more and more positive. So here, the rates of change are increasing. They're going from negative values to more positive values. So a concave up graph has an increasing rate of change, right? The y values aren't always increasing because we can split this into two. On the left side, the y values are decreasing, and on the right side, the y values are increasing, but the rate of change is always increasing. Okay, for your concave down graph, here we have a very steep positive and then a less steep positive, and our slopes are getting smaller and smaller. They're getting more and more less positive until we get to 0, and then the slopes are becoming more and more and more negative. So in this case, our rates of change are decreasing. Our rates of change are decreasing. So we can, of course, split this into two. On the left side, the y values are increasing while the rates of change are decreasing. And on the right side, the y values are decreasing. Okay? So if we're talking about concavity, that's talking about your rates of change. The rates of change. Okay, so if your function is positive, that means all of the y values are greater than 0. Okay, if your function is positive, all of your y values are greater than 0. And of course, if your function is negative, your y values are less than 0. So let me give you a graphical look at this. Okay, so here are some graphs. The y values are all above the x-axis. The y values are all below the x-axis. Okay, as opposed to when is your function increasing or decreasing? That means the y values are getting larger if we have an increasing function, and we have the y values getting smaller if it is a decreasing function. Okay, so think about a cubic. The y values are always increasing, right? Whether they're positive or negative, it doesn't matter. The y values are always getting larger as the x's get larger, right? So it's the inputs. How are the outputs behaving as the inputs increase? So for an increasing function, as the outputs increase, as the inputs increase, the outputs increase also, right? So x's are inputs, y's are outputs. On this one, as the x's increase, the y values are decreasing. Okay? The y values are always getting smaller as the x's get larger. The outputs are decreasing as the inputs are increasing. Okay, next we're talking about rates of change. If we have a positive rate of change, that means your slope of your tangent line is positive, right? It's going in an upward direction. A positive rate of change means we have a positive slope. And a negative rate of change means we have a negative slope. The tangent line to our graph is negative, right? Your slope. Remember, rate of change is talking about the slope of your line touching your graph. Okay? So if your rate of change is increasing, that means it's going from maybe negative to less negative to less negative to 0, and then it's getting positive, right? Our slopes are getting steeper. They're getting more and more positive. So it could be from -7 to -4 to -3, right? That is increasing because our numbers are going from left to right on the number line. If those are the slopes of your tangent lines, then the rate of change is increasing. Okay, and if your rate of change is decreasing, that means it's getting more and more negative. So it could be going from something very positive, something very positive to something less positive. Right? Your slopes are decreasing. So maybe we had a slope of 4, and now we have a slope of 2, then we have a slope of 1 and 0. Right? Our slopes are going from positive values moving to the left on your number line. So your rates of change, the slopes are getting less and less positively steep. Okay, a linear versus a quadratic from a table. Okay, from a table. Remember, we did a whole entire worksheet where we were given this table of x and y values. And what we did was we looked at the change in x, right? So we looked at the change in each one of these terms, and we compared it to the change in y. Okay, so if our comparison were constant, if all of these gave you the same fraction or the same divisor, then we had a linear rate of change. Okay, if you compare delta y over delta x, and these are all constant, right? Your delta y over delta x's are constant, then you had yourself a linear equation. Okay, and if that didn't happen, then we looked at these guys. How are your delta y's changing? Okay, if the change in delta y is constant, okay, then we had a quadratic. So if your first one is not true, then we look for your second. Okay, because we're always looking for a linear first. We're comparing our delta y over our delta x, or change in y over change in x. And if that's always 2, then you have a linear equation from your table. If it's not, but then your delta y's have a constant between them, then we're looking at a quadratic. Okay, rates from a graph, tangent lines versus average rates. So let me draw an example of a graph here, just for fun. So a tangent line is one that touches your graph in exactly one place. Okay, and we're going to estimate this because we need to have calculus techniques in order to actually find it. So that's a tangent line. It touches in exactly one place. But a average rate, right, uses 2 points. So maybe we can find the average rate from this x value to that x value. Okay, represented by the slope of this secant line. Say this is called a secant line. It has 2 points. Okay, sometimes we can pick 2 points that don't have an average rate of change, right? The average rate of change is 0. Okay, versus, right, a tangent line. Okay, so we found intervals, or we can find average rates, okay, which are just linear. Right? Average rates means slope. Anytime we see rates, we need to think about slope. What is the slope of the line that we are talking about? Okay, and then we had average rate of change, right? That's an equation. That's y2 minus y1 over x2 minus x1, right? That is an equation for slope. Your AROC, your average rate of change. So if they give you 2 x values, right? If they give you 3 and 7, that means the 3 is your first x value and the 7 is your second x value. So we need to use your equation in order to calculate the first y value, and we use your equation in order to calculate your second y value. Okay? If you're given an equation, if you have a graph, then you just match up what is the y value that goes with that corresponding x. Same thing from a table. What is the y that matches up with your x? Okay, it's when you have an equation that you have to do the most work, because you have to calculate your y2 and your y1 before you plug it into your equation. Okay, our end behaviors. Okay, so we wrote this formally with the lim notation. We wrote lim as x approaches infinity. Okay, and this is what was happening to the graph on the right side of our graph. Okay, and then we had what's happening on the left side of our graph. Lim as x approaches negative infinity. okay, of your function. And we had two options, right? We had two options. Either your graph was going up to positive infinity, or your end behavior, the graph was going, the arrow was going down to negative infinity. Okay, you guys did really well on this the day that we took notes over it, right? Writing these limit statements and deciding based upon two things. Is your function an even function? Okay, is your function even? Or is your function odd? Right? Is it x cubed? Is it x to the fifth? Is it x squared? Is it x to the fourth? Right? Even polynomial powers versus odd polynomials. And then we had to decide, is it positive or is it negative? Okay? And we decided that all positive even polynomials, right, they both went up to infinity. Both of your limits on the left and the right side were positive infinity because your end behavior, your arrows point up. And for negative evens, your arrows point down, so both of your end behaviors go to negative infinity. And we decided that for odd functions, they always behaved opposite. So an odd function, if it's positive, the right side goes up to infinity and the left side goes down to negative infinity. If it were a positive odd function, and then if it were a negative odd function, it did the opposite. The left side went up to infinity and the right side went down. So odd functions always do opposites. One goes up, one goes down. Even functions, they do the same thing. Both go up or both go down. Okay, which brings us to our point of inflection. Our point of inflection is where your graph changes from concave down to concave up. Okay, so this is the front side of our review, things that you need to know. So make sure you're looking back at the problems we did in class and on your assignments that would help you to know what to expect mathematically speaking.